Hey everyone, welcome back. My goal is to teach welding symbols for groove welds, but in order to get to that point, I think it's important for me to explain and for you to learn about the differences between fillet welds and groove welds, the elements of a groove weld, and how we take that to prepare our materials. And then once we get through that, then we can get into the welding symbols. I'm going to be welding together some T-joints using fillet welds. I'm going to be doing a T-joint using a single bevel, and then we'll get into some actual pieces that have been welded together using groove welds, and I'm going to cut those into sections, and we're going to take a look at the fusion and penetration that each weld has and what each weld can provide, and we'll look at the differences and we'll talk about why we use groove welds versus fillet welds in certain applications, and we'll talk about all the other good stuff. So to start us off on the work table, I have some plates that are 1/4 inch thick, I have some plates that are 1/2 inch thick, and I have some plates that are 3/4 inches thick. And then I've got some plates over here that are already beveled and ready to go. And so again, what I'm going to do is I'm going to take these three groups of plate and I'm going to weld them together in a T-joint using 6010 and 7018. I'm going to be doing 6010 on one side, 718 on the other, so that way we can see the difference between each electrode. And this is also going to show us the amount of penetration that we can achieve at various thicknesses of materials without beveling the material. And the first weld that I'm going to be laying down is on the 1/4 inch thick plate, and I'm going to be doing this with E6010 welding electrode. I've already wire wheeled the two pieces, but I'm going to go ahead and wire brush it, just in case, get any last second debris off of there. I'm going to tack the pieces together, and then I'm going to go ahead and put the weld bead in. I should also mention that the variables I'm going to be using are going to be fairly consistent, and starting with this first fillet weld, I'm going to be using 75 amps for this E6010. And once I finish this weld, I'm going to chip the slag off. I'm not going to be hitting it too hard with the chipping hammer. I'm more or less going to be dragging the hammer across the surface. The slag isn't really thick with 6010. You can just scrape it off. And then I'm going to go ahead and brush it really good with a wire brush. That's going to allow us to visually inspect the weld just to make sure that everything looks good. There weren't any major mistakes. I don't have any improper fusion, anything like that. And if we take a look at the back side, you can see that obviously I didn't melt through. So, who knows what our penetration is going to be at this point. Now that I've got the fillet weld on the T-joint completed with the E6010 electrode, I'm going to move on to another T-joint and fillet weld using E7018. Again, this is going to be on 1/4 inch thick steel plate. I'm going to follow the exact same procedure as with the 6010. I'm going to tack the two pieces together. Then I'm going to place my weld in. I'm going to chip the slag, brush it, visually inspect it, and then we'll move on. I should also mention that for the E7018 electrode, I'm going to be using an amperage of 135. Alright, so I finished with the 7018 weld. I'm going to go ahead, chip it off, brush it with the wire brush, just like with every other weld. Now the slag is going to take a little bit more effort to remove. And so again, I'm just going to lightly tap on it until it chips off. I'm not going to use it, like a standard hammer. We shouldn't really be using that much force, just enough to remove the slag. And then after that, we're going to visually inspect it. Once I'm done brushing it, we're going to go ahead and take a look at the back side, look at the bottom. We can see a little bit of heat kind of pushing its way through, but again, we didn't penetrate all the way through to the back side, or we didn't melt through, so we probably got a little bit better fusion because of the higher amperage, but we won't really know until we cut this open. So let's just keep moving on. Now that I have both T-joints done, I'm not going to cut them just yet. I'm going to wait until I'm done with all the others. Then I'm going to take the T-joints over to our bandsaw, cut them in half. That way we can take a look at the cross sections, and I'm going to etch the very edges and the welds, and then that's going to allow us to see the exact profile of our weld. We're going to be able to check for fusion and penetration. Okay, so we're done with the 1/4-inch plate. Now let's move on to the 1/2-inch plate. You can see that I've used a wire wheel to clean up the areas that are going to be welded. I'm just going to tack these two together. I'm going to weld 60-10 on one side, 70-18 on the other. And once that's done, or when all the other pieces are done, we're going to cut this in half and we're going to inspect the welds. And I'm not worried about doing a second T-joint because 1/2 inch is pretty thick. I'm pretty confident I'm not going to penetrate all the way through and meet, both welds in the middle. So, I'm just going to do one weld on each side, then we'll cut it in half and, see what it looks like. And of course, once I'm done with the weld, I'm going to chip the slag off. I'm going to brush it really good, visually inspect it for any major flaws, and then before moving on to the second weld on the back side, I'm going to let this cool off to the point where I can grab it with my bare hands. That way I can make sure any heat from the first weld has completely dissipated and isn't going to assist the second weld to penetrate deeper than it would have if this T-joint were fresh and just starting out at room temperature. Okay, so I went ahead and I skipped past the cooling time just to get right back into welding. I'm going to weld the backside with 718 with a simple stringer bead, nothing more. And my amperage again is going to be 135. And then once the weld is done, we're going to go ahead, chip the slag off like we normally would, and we're going to brush it off. Just make sure that you're using light taps and you're scraping the surface of the slag with a chipping hammer. We're not using the chipping hammer like an actual hammer. We're not delivering hard blows to the weld, because by doing so we're going to be creating little divots in the weld, and that can actually cause stress points that can lead to cracks later on. So again, light taps, scrape the surface of the weld and slag with the chipping hammer. This should take minimal effort. Okay, we've got the 1/4 inch out of the way, we got the 1/2 inch out of the way. Now it's time to move on to the 3/4 inch plate. This stuff is a lot thicker than the other plates, as you can see. I'm going to follow the same procedure, tack them in place, weld one side with 6010, let it cool off, weld the other side with 718. And once again, I'm going to go ahead and let this T-joint cool off to about room temperature or to where I can handle it with my bare hands. Once that's done, I'm going to flip it over and I'm going to weld the opposite side with 718. Okay, now that that's done, I'm going to go ahead and let it cool off till I can handle it with my bare hands. Then we're going to take it on over to the bandsaw with the other pieces and we're going to cut them in half. The first one I'm going to cut in half is the 1/4 inch plate with the 6010 weld. Now that I've got this first one cut, we can go ahead and take our initial look at the cross sections. It looks pretty good so far, but we really aren't going to know until we etch this. So I'm going to put these back and we're going to move on to the next one. Next one is going to be the 718 weld, also on the 1/4 inch plate. And once we're done cutting the T-joint with the 718, we can get an initial visual inspection going on at the cross sections. But I want to remind you that we're not really going to know for sure of any flaws or anything like that until we etch these. The next weld that we're going to be cutting in half is on the 1/2 inch plate. This is with a 6010 weld on one side and 718 on the other. And one more time, this is the 1/2 inch plate T-joint. Just like with all the other pieces, once they're done getting cut, we can go ahead and take our time to do an initial visual inspection, just to kind of make sure that everything's looking good. We don't have to make another weld because of obvious flaws. This one looks good so far, so I'm going to go ahead and keep it for the etch, and then let's go ahead and start cutting the next one. Okay, so now we're moving on to our 3/4 inch plate T-joint with 6010 on one side and 7018 on the other. It's funny, you can see the heat or the steam kind of coming off of these plates from the coolant, just from how hot these plates got while the bandsaw was cutting through. But no worries. And so again, like with all the other pieces, we can take time to do an initial inspection. Again, they look pretty good, so I'm going to save these for the etching. And before I forget, let's go ahead and weld up the very last T-joint. So this T-joint is going to be out of 1/2 inch plate, both pieces. One side is going to be beveled, but not the other. This is just going to show you later on how we can increase the amount of penetration that we get by beveling plate, or essentially creating a groove. Okay, so this is going to allow us to penetrate even deeper. But don't take my word for it. Let me go ahead and just weld this up. I'm going to do the same thing, cut it in half, and then we'll etch it later on. All right, now it's time to etch. We're going to begin with our 1/4 inch T-joint welded on one side with E6010. You can kind of look at the cross section already and get a good idea of the profile of the weld, but etching is going to make it a whole lot easier for us. I don't have the actual acid you're supposed to use to etch metal. Something like that I wouldn't be able to use in my house or in a household environment, but the poor man's version is to use some Loctite rust dissolving liquid, or basically navel jelly. This gives you the same effect, not